Our next lesson is called Product and Quotient of Square Roots. So to begin our lesson today, I would like you to complete the opening exercise. Using your calculator, simplify the following to find the product or quotient. So hopefully we remember product means the answer to a multiplication problem. Quotient means the answer to a division problem. So at this time, please pause the video and complete the charts that you see underneath the opening exercise. Okay, at this time you've had a chance to try the opening exercise on your own. Let's go through our answers, okay? So the square root of 13 times the square root of 13 should have just been 13. It eliminates the square root symbol. Square root of 25 times the square root of 25 should be 25. And the square root of 4.8 times the square root of 4.8 should just be 4.8. Okay, for the square root of 16 25ths, you would take the square root of each part of the fraction. So you'd have the square root of 16 over the square root of 25, which means we end up with 4/5. For the square root of 100 ninths, you would take the square root of 100 over the square root of 9, so you get 10 thirds. And for the square root of 1/4, you would take the square root of 1 over the square root of 4, and you would get 1/2. So now it says simplify the following product and quotient, but what's happened is they've changed them into variables. So the same idea happens. This square root of x times square root of x, if you want to think about what you're multiplying underneath, you would get square root of x squared, but the square root of x squared is just x. So just like with the numbers you saw above, if you take and multiply by itself with a radical, you basically just eliminate the radical symbol, okay? On the other side, with our quotient, you would take the square root of the top and the square root of the bottom. So you would end up with x over y. And then we were asked the question, what set of the real number system would the products and quotients belong? All of these numbers are rational. Okay? So let's look at some examples of multiplying and dividing eventually, okay? The following expressions that contain a radical. So when we are doing these, know that when you're completing them on your own, you can always check your answers with your calculator to make sure that the beginning multiplication expression ends up matching the final answer that you would get, okay? So when we are multiplying, we want to multiply what is similar. So we are going to take 4 and 5 and multiply them. And then we are going to take the radicals and multiply those. So square root of 2 times square root of 3. So we would get 4 times 5, which is 20. And on the other side, the square root of 2 times the square root of 3 would be the square root of 6. Now, if that needed to be simplified, we would want to make sure that we do that, but there is no way to break down the square root of 6. So this is our final answer. And if we were going to classify it like we did in the previous question, although it does not ask us to do that, we'll just kind of add it in. This would be an example of an irrational number. Square root of 6, 6 is not a perfect square. So if we times that by 20, still have an irrational number. All right, let's look at number 3. We have 2 square root 10, but then squared. So let's think about what this really means. That means our base is 2 square root 10, and we are going to multiply it by itself 2 times. That's the meaning of the exponent. So 2 square root 10. So again, do the things that are similar. That means we've got 2 times 2, and then we've got square root 10 times square root 10. So 2 times 2 would give us 4. And then we know from our chart up above that if we take the square root of 10 and times it by itself, it just gives us 10. So my answer here is 40. And this would be an example of a rational answer. Let's look at, I went out of order. I went 1, 3. That's okay. Let's look at example 2. So in example 2, again, make sure you multiply what is similar. That would be the 3 times the 5 and the square root of 6 times the square root of 2. So 3 times 5. And then square root of 6 times square root of 2. We have 3 times 5 is 15. Square root of 6 times square root of 2 would be the square root of 12. Now here's an example of a radical that is not in simplest form. We can take 12 and simplify it. So this would become 15 times the square root of 4 times 3, because the largest perfect square factor of 12 is 4. So we have 15 times 4 is a perfect square, and the square root of 4 is 2, so that comes out from underneath the radical, and square root of 3 stays inside. So 15 times 2 means we have 30 square root of 3. And this is an example of an irrational answer. Square root of 3, 3 is not a perfect square, so when you times it by 30, still irrational. Okay, let's look at example 4. We have 1/6 square root 6 times 5 square root of 216. So again, we would do 1/6 times 5, and then we would have square root of 6 times square root of 216. So this would be really over 1, right? So we would have 5/6, and then we would end up with the square root. If we multiply those two numbers, we get 1,296. So we would end up with 5/6. And if you take the square root of 1,296, you actually get a very nice number. The square root is 36. So you would write 36 like that. And now you just have to do your math. You can use your calculator. You can cross cancel and realize that that's 6. Okay, 6 goes into 36 6 times, so 5 times 6 is 30. So our answer here is 30, and that is a rational number. So now that we've gone over all the multiplication, let's take a look at what happens with our division. Okay? So, what is the simplified form of the following expressions? Very similarly to the multiplication, you're going to now divide the parts that are like. So when I see 8 square root 48 over 4 square root 2, I'm going to do the 8 divided by the 4, and then I'm going to do the square root of 48 divided by the square root of 2. So now I know that 8 divided by 4 is 2. And I'm going to divide my numbers. The square root of 48 divided by the square root of 2, which is the square root of 24. So I have 2 square root 24. Now again, I have to make sure that radical is in its simplest form. 24, square root of 24 can be simplified. So I will continue and say 2 times the square root of, okay, the largest perfect square that goes into 24 would be 4. So this is going to be 4 times, we would need it to be 6. So this is 2. Can I take the square root of 4? Yes, I can. It's 2, so that comes out from underneath the radical, but square root 6 is not a perfect square, so that stays underneath. So now if we simplify, 2 times 2 is 4, square root 6. So I know that that is an irrational number. All right, let's look at number 6, 25 square root 24 divided by 5 square root 2. So again, do the parts that are similar. We would do 25 divided by 5, and then we would do square root of 24 divided by square root of 2. So 25 divided by 5 is 5. And the square root of 24 divided by the square root of 2 is going to be the square root of 12. So again, we check to make sure it can't be simplified, but it can. 12 can be broken down. So this will be 5 times the square root of the largest perfect square, that is a factor of 12, would be 4. And we would have to multiply it by a 3 to make it the 12 we need. So we have 5. Can I take the square root of 4? Yes, I can. It is 2, so it comes out from underneath. I cannot take the square root of 3 nicely. That is not a perfect square, so it stays underneath. So now we know 5 times 2 is 10. So we have 10 square root 3. So we'll go back and circle our answers so it's nice and easy to read. And this would be another example of an irrational answer. Now, With division, we run into this special circumstance with needing to do what's called rationalizing the denominator. So when there is a radicand, which is what's underneath the radical symbol, in the denominator of a fraction that is not a perfect square, then you will need to rationalize the denominator for the fraction to be in its simplest form. So I'm going to highlight that word. It has to be the radicand in the denominator, and when it's not a perfect square. That's our circumstances that we are concerned with. Okay? So let's look at number 7. Right now, if we follow the rules that we've been following with division, you take the square root of the top over the square root of the bottom. That's what we've been doing in the beginning with the opening exercise and moving forward. So the problem with that is you can see right now I have a radical in the bottom. And even if I simplify this, I can take the square root of 1, it's 1. But I end up with square root 3 in the bottom. We cannot leave the answer like this. You're not allowed to leave a radical in the denominator. It's not in simplest form. So we are going to do what's called rationalizing the denominator. Whatever is in the denominator position is what you're going to multiply by. So if you have square root of 3 in the bottom, you are going to multiply by square root of 3 on both the top and the bottom, because that means you're basically multiplying by 1. Square root of 3 over square root of 3 is 1, isn't it? So if I write it like a fraction and we're multiplying, okay, you are multiplying by 1, but writing it in radical form. The reason we do this is because now 1 times square root of 3 is square root of 3. And if I take a square root and times it by itself, we know from before it eliminates the square root symbol. So square root 3 times square root 3 is just 3. And now I have an answer without a radical in the denominator. I have rationalized the denominator, and we see that this is an irrational number. Okay? In number 8, we have the square root of 6 over the square root of 7. So we are going to rationalize the denominator by multiplying by the denominator, which is square root of 7, over square root of 7. So this now means I have the square root of 6 times the square root of 7, which is the square root of 42, over the square root of 7 times the square root of 7, which is just 7. Now, if I could simplify, I should, but there is no way to break down the square root of 42 into a perfect square factor times another number. So that is my answer. And again, we have an irrational number. So in the last part, I did this along with you in this note since you were watching the video version of this lesson. So it said classify the answers from example 1 through 8 as rational or irrational. So we've been doing that along the way. If we go back and take a look at rational, we had only 2 responses, I believe, that were rational. And that was number 3 and number 4 there. We got a 40 and a 30. So we will go back and add this to our response. Our rational numbers were number 3 and 4. And then for irrational, it was everything else. We had 1, 2, 5, 6, 7, and 8. And that concludes your lesson on product and quotient of square roots.